Good morning, good evening, depending on which time zone you are turning in from. Welcome to our Zebra Dev Talk today. We are excited for you to join us for this discussion about shielding Android, advanced strategies for interface protection, and code obfuscation. Before we kick off, let's quickly cover some housekeeping items. This webinar is being recorded and will be up on YouTube in about a week. All attendees are currently muted. If you got a question during the session, please use the Q&A feature in Zoom. We'll have the Q&A segment at the end, and we'll do our best to answer your queries if time allows. Currently, all attendees are muted by default. If you do have a question through this meeting, please use the question feature within the Zoom. All right. Now I want to share a quick video with you that highlight Zebra Developer Portal, and the video goes through some key tools and resources and things that you can access on Developer Portal. Let's play the video.
Learn, connect, build, all in one place. The Zebra Developer Portal. As an enterprise software developer, you need fast and easy access to technical information, documentation, and tutorials. You also want to connect with your peers, share and consume information to build your knowledge and competencies. The updated Zebra Developer Portal has you covered. Product pages give you quick access to product overviews, tutorials, documentation, use cases, forums, and blogs about specific products, all indexed with quick links to key developer information to help you build. Forums within the Zebra developer community make it easy to connect with your peers and find answers to your specific development questions to help you collaborate and build. Community blogs feature content from Zebra engineers and other developer experts, all sharing the latest technologies and tools to enable your development on enterprise devices. Developer events provide knowledge and networking opportunities for our developer community. Be sure to scroll through the upcoming and past events for registration information and access to on-demand content. The Zebra Developer Portal provides enterprise developers like you with the tools and services you need to build your edge. With an easy-to-use interface, you will be sure to find the resources and connections you need to build all your enterprise applications. Devices built by us, apps built by you.
All right. Well, in addition to our developer portal, we invite you to join our developer community. Join us on LinkedIn, Twitter, which is now known as X, GitHub, and listen to our first series of our developer webcast podcast as well. We will share those links later today in the chat, so be sure to follow them and connect with us. We also have upcoming events. You can see Zebra Dev Team at DroidCon Berlin, DroidCon London, and DroidCon New York this year. If you happen to attend those events, be sure to come and visit our booth, and don't forget to collect those cool swags. Over to you, Sairam.
Okay, thank you, Priyanka. Okay, hello everyone. I'm Sairam Kotiri, Principal Engineer. I'm working with Zebra more than 18 years. So welcome to today's Dev Talk on Android shielding, secure interface, and code protection. This is the third session in our security series. In the first session, we discussed threat modeling, securely acquiring and utilizing sensitive data using tools like Stride and Dread. In the second session, we covered critical elements of contemporary data, includes scope storage, data in motion, data at rest, and credential management. Next slide, please. Okay, in today's session, I'm going to talk on interface protection, code obfuscation, particularly going over interface protection, a small case study on recent attack registry, code obfuscation, what are the available reverse engineering techniques, a demo on reverse engineering by leveraging the obfuscation techniques, and we will finish off with a Q&A session. Next slide, please. Before we going into the interface protection, right? In Android, the main components that work together to build an application are activities, services, content providers, broadcast receivers, and intents. Activity represents a single screen with a user interface in an Android application. Example, in an application, email app, different activities might handle displaying a list of emails, composing a new email, and reading an email. Service. It's a component that runs in the background to perform long-running operations without a user interface. Examples, a music player service, which runs in background while you are using an application. There are multiple types in services, local and remote. And interactions with the service mainly uses ideal interfaces or a callback. Content providers. Content providers supplies data from an application to another application based on the request. Example can be data can be stored in various locations like a file system or a database and accessed by other applications using content resolver classes. Broadcast receivers, they respond to broadcast messages which are received from other applications or a system. So an app might receive a broadcast when new data is downloaded and is ready to use. Next slide, please. And the next one is intent. Intents are basically on objects which are used as an inter-component signaling in Android. They are a way for different parts of your application to communicate within each other. Intents are essentially messages that can be used to request an action or deliver data. You can use intents for a variety of purposes. If you want to start a user interface or send a message between the components, or you want to start a background service. Next slide, please. If you look at these components in a holistic view, so these key components can interact with each other in a variety of ways to share data and functionalities. If you look at the starting an activity for a result, activities are built blocks of an Android application. They represent a single screen with a user interface. So typically, you can start an activity or stop the activity. Similarly, communicating with the services, you can start the service or stop the service, and you can get back the service result back. And content providers, you can query a content provider and you will get back a result from the corresponding application. And intent broadcast, you can receive the intent broadcast once you register it, and you will receive back the response from various system or activity or services. Next slide, please. Okay, now comes back to the interface protection. So we have various components in application which allows applications to interact with multiple services or intents or broadcast receivers. But how do we protect it? So application security is the practice of protecting applications from unauthorized access, use, disclosure, disruption, modification, destruction. So there are many things. There are many reasons why application security is important. The primary thing is we want to prevent unauthorized access. Basically, preventing unauthorized access protects application. Exploiting by unauthorized users, hackers can exploit these vulnerabilities to steal data or installing a malware or disrupt operations. Even though I don't gain anything, but I will cause application to not respond or DOS kind of attacks. And the second thing is ensuring the data integrity. This safeguards the communication between an app, components. Data breaches can occur when this communication is intercepted. Compliance. So if when you're developing an application, you need to meet some security standards and regulations to protect user privacy and data. Next slide. Okay, what are the methods of interface protections? You can broadly I categorize into three different things: access controls, encryption, and input validation. Access controls is by means of implementing strict access controls for sensitive applications in the form of APIs. This means only authorized applications will be allowed to access these interfaces. You can use permissions to control these access to these interfaces. Permissions are security mechanisms that allows you to specify which applications can access certain parts of your apps, data, and functionalities. The next one is encryption. Encrypting the data transmitted between components. This will help to protect the data from being intercepted by attackers. You can use Android key store system to encrypt and decrypt data, because all modern Android devices, the key store is backed by a secure element called trust zone or much more beyond. The Android key store system is a secure storage mechanism for cryptographic keys. It provides a tamper-resistant environment for storing keys, and it helps to ensure that keys are not leaked to unauthorized applications. The next one is input validation. You must validate all the inputs to prevent injection attacks. Injection attacks are types of attack that can be used to inject malicious code into an application. By validating inputs, you can help to prevent these attacks. There are a number of different types of injections attacks, including, no, I think we are still there, okay. Including SQL injection and command injection. Okay, next slide. Let's look into a sample manifest, how it looks like. Okay, I'm going to present an unsecure manifest which has multiple interfaces defined. As we know that the Android manifest file allows developers to define an access control policy for access to components. You can see here, you have an activity, and you have a service, you have a content provider. If you look at this image that I'm showing, right, it contains a snippet from an Android manifest file that defines several components that are marked as Android exported to true. This means that these components can be accessed by any application on the device. This can be a security risk if these components are not properly secured. An attacker could potentially exploit these exposed components to steal data, inject malware, or other malicious actions. In this specific examples, the manifest file contains the following unsecure components. You see a service named My Insecure Service, My Insecure Receiver, My Insecure Provider. All three components are exported, which means that they can be accessed by any application on the device, for example, by an angry bird. The risk, what risk it poses because I'm exporting it? If you look at My Insecure Service, could exploited by an attacker to steal data or perform other malicious actions. Like any service you read and write, it will expose a couple of APIs, public APIs. So without me requiring additional privileges, I can bind to this service and access the APIs. And My Insecure Receiver, it could be another exploit by an attacker to inject malware into your application or intercept the sensitive data. And Insecure Provider, this could be exploited by an attacker to steal data from your application or inject malicious data into your application. Okay, next slide, please. Okay, so what I did was, I know that there are potential issues in my earlier manifest. So by using a couple of static analysis tools, I found that, okay, these are all potential for me. So there are ways to protect this. If you look at this interface protection in this secure manifest, which I populated just now. Now my service I added with a control with external access even though I exported to true, but I added a custom permission called a secure permission. So any application can be accessed this service only if it has this specific permission, and this specific permission, I'm going to add as a signature level. That means if I sign with same key as what I signed this application, they can access it. There are multiple ways to address this kind of thing, whether just by signing, or you can add individual API level check to see you are getting a legitimate call from the application. The second one is, did I lost it? 1 second, I think it is. The receiver. My receiver also, it's not, now it is not exported, but I am securing with the permissions. And the third one is content provider. The receiver is not exported. The content provider is not exported, and it is protected with the read and write permissions to control access strictly. By following recommendations, you can help to improve the security of your Android applications by reducing the risk of unauthorized access to your interface, protecting your data from theft or modifications, preventing attacker from injecting malicious code into your application. Next slide, please. Let's look into a recent attack that is today. Next slide. If you look at in the earlier slide, right, in my manifest, I have content provider. Originally, it was not protected properly. That means any application can override the content of the file or URI or the data which I'm going to send to my receiving application and do a malicious activity. If you look at the dirty stream attack, it is a malware attack that exploits existing Android content provider system. This system is typically designed, normally a content provider system is designed to manage structured data and facilitate safe data sharing between applications. But dirty stream finds a way to bypass these safeguards. So now let's see what are the potential ramifications. I can alert the Android app settings by receiving app settings, making it communicate with a server controlled by an attacker. Data theft, I can steal the user's authentication token or on any other sensitive data, or I can inject a code for execution by an arbitrary code, injecting a malicious code into a receiving application's native library. These ramifications highlight a critical security risk posed by dirty stream, making it essential to strengthen the validation and security practices in application development. Next slide. If you look at how dirty stream attack today is happening, so it leverages file sharing system. Normally, content providers, how it works, the malicious app will send a file with the exact name as what the receiving application is expecting it, but with a misleading content of the file name. The target app is not aware of the content, rather it finds the file name and it processes the file, and it will overwrite the existing data of the current file, which is a malicious payload. So that's how, without knowing the targeted application, because you are exposing in content URI by means of a hard-coded file name, and the content, what it does is totally different than what you're supposed to be doing it. because the target application is not doing an input validation. That means what are the contents of this application. Okay, I'm sending a modified payload. Will I get a user notification? How do I pretend that I don't make it aware of to the user? Okay, next slide, please. In case of dirty stream attack, right, what it was doing is they creating a custom file provider to share a payload, and then modify the query method to return a mal-crafted file name. That means this involves changing the way the file provider responds to request for files and returning a mal-crafted file name. The attacker can trick the vulnerable application into opening the wrong file and modify the open file to return a file descriptor to the payload. In these transactions, right, will make sure that the attacker will make sure that there is absolutely no user interaction, because if there is an user interaction is required, user is knows okay, something is wrong is happening. That's why they will try to avoid the user interaction. So that's where you could able to achieve the attack using this content provider. Okay. The overall lessons from the data stream attack is don't trust the file names from other apps when caching the files. That means when you receive a file from another application, don't rely on the file name it provides to store and download the content. Instead, generate a new file which is unique for the cache file and use the content. But before you consume the content, right, do an input validation so that when you're trying to load or save the content of the file, by means of some checks, input validation, you're making sure that you're not doing something harmful to the system. So for those who are looking to deep dive into this vulnerability, I'm providing what are the Microsoft exposed this, found this MCVE, and what are the Google response for this one. This is available, and what are the applications that are used to do this attack, the mitigations or proposals available. Okay, so interrupt protection is an important part of security or securing your applications. There are a couple of tips that I provided, like interface protection, like by means of services or intents or activities or content providers. So you can always see that I classified it into three different things: services, intents, and content providers. Make sure to protect the services if you want to export it, but the recommendation is don't export unless it is really required. If it is required, make sure to enforce a couple of permissions and provide access based on the request. Similarly for intents also, intents are very broader because Android board can send broadcast an intent, so that Angry Birds can broadcast intents, and which does a malicious activity just by not opening anything. So it will not allow you to do any other applications. So content providers, the classic example is dirty stream attack. Yeah, next slide, please. Code obfuscation. Yeah, next slide. Okay, by definition, what is obfuscation? Yeah, to make it unclear that I say something you will not understand. Somehow you could be able to understand it, and deliberately I'll be confusing you. That's what it is, obfuscation. Okay. Next slide. What are the obfuscation goals? Makes the sensitive assets harder to find and want to limit or minimize the cloning or application repackaging. The inner implementations will be protected, and any other security features inside an application all protected by means of different mechanisms. That's the goal of an obfuscation. Overall, it is to make attackers or reverse engineering job make harder. It's not that to make it easier. Next slide, please. Why you require an obfuscation? When you upload your application to a Play Store, anyone can download it, and using available tools, I can extract the code. I'm extracting because it is not protected by default. After extraction, also known as this reverse engineering, I can fetch the intellectual property of your code, because every developer's code is their own IP. If someone can understand how you implemented your application and how it is working, I can potentially steal your code, or I can use as it is your code, or I will clone your application into similar application. As well, I can also find, is there any loopholes or vulnerabilities that I can exploit to inject or modify the behavior of an application, so that I can modify your application by removing some restrictions, and I can change the workflow of your application. Obfuscation will help in these kind of risks. Next slide. Code obfuscation is the process of transforming code to make it difficult for humans or computers to understand. It is a very generic terminology. Think of like a perfectly readable sentence and scrambling the words around so that it becomes a nonsensical. The code will still run and produce the same output, but it will be much harder for someone to read and understand how it works. Why use code obfuscation? There are two main reasons to use code obfuscation. Number one, to protect your IP, intellectual property. Your source code is your IP. That's what I discussed earlier. Just like a trade secret or a patent, it could be a patent, we don't know. By obfuscating your code, you can make it more difficult for others to steal your code or copy your ideas. And number two is to prevent reverse engineering. Reverse engineering is the process of taking apart Okay, sorry, I got a lot of notifications from the session learning, I think. Okay. To prevent reverse engineering, basically, why I want to obfuscate is, okay, I want to discourage people to reverse engineer my application. I can make it more difficult for attackers to reverse engineer my application and find the vulnerabilities, if at all anything is available for the injection purpose. There are a number of tools available that can be used to obfuscate the code. Some of the most popular tools are ProGuard, which is a free open source that is coming from the Android Studio. You can see it. There's a latest tool called R8, which is successor to ProGuard. It's again from the Google. And these two are ProGuard and R8 are open source tools. There are some commercial tools are available. To name it, DexGuard, Dasho, Arxon. These are all the vendors, popular vendors, I will say that. Okay, they're also providing much more versatile tools if your application requires to protect much more than what the open source tools are providing it. I'm going to show a demo between the classification of these three categories. Next slide, please. Okay, to classify it, I will be categorizing it two different. One is free and the commercial. Free by definition, ProGuard, R8. Commercial, DexGuard, Dasho, Arxon. These are popular ones, that's why I'm mentioning it. It's not a recommendation. There could be many other things that are available outside. Next slide. ProGuard is an open source tool that was once widely used for code shrinking, obfuscation, and optimization in the Android build process. It offers basic functionalities to achieve these goals. If you talk about R8, it is successor to the ProGuard and is now the default tool used for code shrinking, obfuscation in Android development. It is more efficient and faster than ProGuard, R8 is, making the build process quicker. What are the key differences? Both tools serve the similar purpose. R8 offers several advantages over ProGuard, efficiency and functionalities. Integration is more easy. It is because Google is heavily promoting this ProGuard/R8 tool. And if you look at your Android Gradle, there is a plugin already available for R8. Although R8 is default, but still, if you already written any ProGuard rules by using old methodology, R8 will still supports it because Google always wants to have a smooth transition for migrating from the projects from old one ProGuard to R8. Next slide, please. Okay, how this ProGuard works. You can have shrinking, obfuscation, and optimization. Shrinking is the process of removing unused code from your application. This can include that a code is never called, which is called dead code, or some code you will use it only in debug builds. There's some classification that you can write your application. You can select your build targets, whether it be debug or release version. Shrinking, you can reduce the size of your application, which can make it faster to download and install. But the other side of shrinking is if you shrink too much, it will be difficult in disassembling during the runtime. So that's why you need to do a balanced shrinking. Optimization is a process of making your code run faster and more efficiently. This can be involved in a number of techniques. So these things are already covered inside the ProGuard or R8. So we just need to use that one. But your configuration or ProGuard rules will make sure that you have a balanced configuration to meet optimization, shrinking, and obfuscation. The recommendation is you can use these three together to get a better performance, size, and security. Let's look into an example. Okay, so I have a class, I have a public class. If you look at it, use a credential. If I disassemble it, I can directly see my class. If I use ProGuard, I use a class renaming in my obfuscation rules. So you can see that class name is changed to A, which is very difficult for attackers or reverse engineering people to understand it, at least initially. But if you spend time, definitely it is possible to map this renamed classes back to the credential manager. But it all depends on what is your intention. It's a cost versus timing. Next slide. You have an application and you have intention to protect it because that application which you are using it, having a trade secrets or a potential IP. So for that, the advanced obfuscation tools are strongly recommended. What are these obfuscation tools are for? So these obfuscation tools will safeguard your IP, like trade secrets, patentable code, or unique implementation. It could be any of these three categories. It's not necessarily patent, but it is unique implementation. Or it could be a patent code which you're not thought of, or if you're unsure about it. Or it could be a totally trade secret. So if you have such kind of requirements, or if it is falling into any of these categories, I strongly recommend to go for an advanced obfuscation tools, so that I will not be getting into the issue of reverse engineering and stealing the data or code. Along with this, I can definitely prevent from reverse engineering. That means I can avoid exploitability of my code. So, and I can always protect the secure elements inside my application. Here my secure elements are, it could be certificates and signatures or some privileges. By using these advanced tools, I can always obfuscate these secure element contents, so that reverse engineer, even though a bad reverse engineer guy could able to do it, it is very difficult for them to understand what are these content. There are some popular tools which are available, as I mentioned it, in reverse engineering it. It's called ProGuard, Dasho, and DexGuard. These are obfuscation tools, not reverse engineering. Next slide, please. I just want to touch upon what are the obfuscation techniques these tools based on. Obfuscation is normally temporary advantages in the ongoing arms race between attackers and defenders. It will delay the process. It's not the final one. There are many different obfuscation techniques that can be used. And the tools are maturing now, and new techniques are being adapted by the vendors. Some of the most common obfuscation techniques includes control flow obfuscation, anti-tampering obfuscation, anti-debugging, string encryption or string cipher, renaming, and shrinking. Control flow is important. This technique makes it difficult for attackers to follow the flow of execution through the command or the code. Even if you able to reverse engineer or disassemble the code, you really can't make out what's the code about it. And similarly, string encryption also. A couple of strings, because if you use the ProGuard, string encryption is not possible because it will not obfuscate the strings. If you want to obfuscate the strings, so you don't want to make it, okay, for example, I'm having some certificates which are in the strings format. I don't want to use ProGuard. I definitely consider obfuscation advanced tools, so that by leveraging string encryption, I can always make it harder for the attackers or impossible for the attackers to know what the string is about it. Next slide, please. Okay, so some of the output after an obfuscation by using advanced tools, you can see in the left side, you can see a control flow obfuscation. In this technique involves making the control flow of the application more difficult to understand. If you look at it here, right, even though you can see a function name, the content of the function name is jumbled. I can't really make out what it is. Because the tool which I used, I enabled control flow obfuscation. The tool took care of jumbling or distorting the content of inside an application API, and it really makes any sense to me because I can't really understand what's the flow. If you look at right side, it's a string cipher. It involves strings that are used in the application. If you use cipher, right? So for example, if you are implementing an application and you are using the strings to store API keys, and you don't want the attackers to know that, okay, what is the string API key. So definitely string cipher will help you there, so that you will not be knowing that what is the string about it. Okay. It could be a API key or some other username. I don't say username, something which you feel that you want to make it obfuscated. You don't want anybody to know it. Okay. Next slide, please. Well, okay, next step is you have obfuscation, you obfuscated. Okay, now let's come more to other direction. So you have a code, you download an application, and you want to do reverse engineering. What is the benefit you will get it? So there are multiple things. I can inject something into the library. I can steal the code. I can manipulate the application, or I will cheat that. Okay, I will inject by injecting and changing the flow. I can cheat that application to do something else. Next slide, please. Okay, so if you look at application, the first step in the Android applications is comparing this Java source code, which you convert into Java bytecode by using Java compiler, Android compiler, and the bytecode will convert into final text file. That's the actual flow of getting an APK. In case of reverse engineering, it is other way. We need tools to convert from DEX to Java classes, from there to Java files. So there are various tools available. One of the popular tools is DEX to jar files, which will convert from DEX file to the human readable format. That's where we can know that, okay, I can read some piece of code where I can understand. Next slide, please. These are some tools which are available for reverse engineering. This can be used to disassemble the DEX files. To name it, DEX to jar, this tool normally converts DEX file into a jar file to a common archive format for Java applications. And there is some of the back small e or small e. This tool is used to specifically converting bytecode. From the Android application, same thing. And IDF Pro also. There are many tools. Okay, let's see that. Let's compare. We spoke about 3 different categories. Okay, ProGuard and advanced tools. So I will take it as, okay, without ProGuard, and advanced tools. In these 3 categories, if I develop an application and by means of reverse engineering, how I'm able to modify or inject something which I'm not expecting as a developer. So next slide, please. Okay, so I'm using a couple of tools called DEX to jar because I want to convert my application into a jar file because I want to read what are the contents of this application. APK tools is another build tool which will help in decompiling and recompiling. So I can extract, modify, and repackage. And JDGUI is another open source tool. The content which I extracted using DEX to jar, I will be using this tool to view the contents of extracted code. And finally, once I modify the code or injected the code using APK tools, I will recompile it back and I need to sign the APK. So I will be using the sign APK after repackaging it done, so that I can use sign APK to install back and see that how it works. Next slide. Further elaboration on this tool usage, DEX to you have to provide an application name for the extraction into the jar file. To view it, open the JDGUI, disassembling using the APK tools. I'm going to extract it, I'll repackage it, and then I will sign back. And I already created my, to sign it, I need keys. So there are many open source, OpenSSL or key tools are available, how to generate keys. So I generated for this test purpose. Next slide, please. Okay, so let's look into. So I have connected my device here. Hold on. Okay, so you can see that there are three different applications here. One is with ProGuard, and other without ProGuard, and without advanced tool. First, I'm using an APK, which is not at all obfuscated using any of the tools. So before me doing any reverse engineering, I installed it. You see that there is a number generated, random number. For now, I hard coded it to 2 lakhs. That is the count. Before me reverse engineer or modify the code, I want to uninstall the application. And now using dex to jar file, I'm going to extract the class to view the contents of this application. Okay, so it is mapping into my system problem. So okay, I have to use a shell script. Okay, so it's trying to. Okay, so now I got my jar file. So let me open this jar file using JDGUI. Okay, this is what the JDGUI looks like. Okay, you can see this. It unpacked the code, and you can see that the com.android.service demo API. So my intention is that I want to see that what is the random number service. So you saw that, right? 2 lakhs is the count which is some number. So you can see that it's a clear text. Everything is a clear text because I am not obfuscated. So I can see the entire source code. Either I can use the same source code, I can flick the logic, or I can copy paste the source code directly. So the get random number, if you look at here, it's calling the get random number API instead whenever I click on the UI button. So now I know that, okay, I can do something with this application. Let me extract the package. APK tool D means disassemble. It creates a smally code so that it is easy for me to update the code and repackage using the APK tool. So now I unpacked it. I know where the code it is. Okay, it is under the smally. The class which I'm looking is in the classes for. So you can see it class com.android.service demo. You can check that random services.smally file is available here. Okay, right. So in this, if you look at right, okay, I know that what is the API, I need to look into it. If you look at the line number 40, okay, fine. Get random number. Get random number is an API. In this, in line 46, right, there is some hexadecimal value 0x3, blah, blah, blah. This is the number which is equivalent to 2 lakhs that which we saw it. So now I want to change this number to something else. What I do is the number which I'm going to convert, I will convert into an hexadecimal. I will update this number I will replace this hexadecimal with my new number. Okay. Okay, yeah, so I'm trying to convert into 2 lakhs 24. That's the equivalent of hexadecimal is 30D40 is the one hexadecimal count. I'm going to use it. So now I updated my Smalley code. So let me recompile it or repackage it back using APK tool. Okay, so I need to provide APK tool B. What is the source code path under the destination APK? So now APK tool build, B is a build command. It is building me back. So I got an unsigned application, which is modified. Now I need to sign. So using APK sign utility and using my predefined keys, I'm going to sign it back. Okay, I said unsigned to sign. Okay, modified sign. Okay, it requires because it's a JKS file. It requires password to be. It needs private to public key pair. So it needs to unlock the JKS. Now let me install this application. Okay, so I have now modified application. Well, let me launch it. Okay, if I click on get random number now, you can see that like I could able to change the value from 2 lakhs to 2 lakhs 24. So I could able to do it because my code was never obfuscated. I would have not spent time in changing it if I could able to see if I don't able to see the source code or the modification that I want to do it. Yeah, that's the value. The updated value is 24, 2 lakhs 24. Now let's look into the obfuscated code using ProGuard. Let me reverse engineer it. Okay, let us convert into JAR file and try to see if I can read any content after enabling the ProGuard. Okay, let's get it. Okay, let me open it using a JDGUI again. Remember, we used this tool to view the contents of this jar file. Okay, so it's better than last one, but still you can see this this random number is still not obfuscated because I can still make out the entire number here. Okay, 2 lakhs, the number, right? It is still available here. That means by following the earlier mechanism, I can still replace the value with something else and repackage and sign it. I can use it. So in this case, I may not be using the logic, but I could able to inject something here. Instead of returning 2000, I may always say that -1. That means it always fail or something else can happen. Okay, so let me show that what is the code I have. Okay, if you look at here, my API, what I'm returning here is, in fact, the original value is 20,000 into 10. That means it become a 2 lakhs. The number, it's a just number. I just put something else. Okay, so even it is a ProGuard, still it's not preventing me from injecting or viewing the code. So now I decided that, okay, instead of this one, let me use an advanced obfuscation tool. So which will give me a flexibility or confidence that, okay, I can't do reverse engineering. Even if I could able to do it, I can't make it out what is the value. Okay. So yeah, using the same JDGUI, I'm option. So I can't really make out anything in this because everything is jumbled. Everything. I can't find anything which is related to this get random numbers or a specific value in this one because everything is obfuscated. If you see that all the classes, everything is. So it's an advanced obfuscation tool by using one of the tools which I listed. Arxon, Dexon, or Arxon, DexGuard, or Dasho. Any of these tools will do the same or the same thing. Because basically they do is the class resource encryption, control flow obfuscation, and string cipher. It's up to you to enable based on your requirement. Okay, next slide, please.
Sure.
Okay, to summarize this commands list, okay, just providing it. Okay, so basically, I installed the first no obfuscation file. The next one is I extracted the jar file, and using the JDGUI, I'm able to view the contents of my jar file, and using APK tool, I disassembled the code, and I modified the small file with my required return value. And using the same APK tool with a different build command, I repackaged the application using APK signer. I signed my application and I installed it. And when I tried it, I could able to inject a new value with the same application. Okay, next slide. Okay, what the summary of this code obfuscation means? Okay, you understand obfuscation doesn't prevent reverse engineering, but it just discourages it. Okay, so it makes the code to harden reverse engineering. That's what we sign using our advanced obfuscation. You can protect the IP protection by using a balanced ProGuard or obfuscation configuration. It can reduce the APK size, but still maintaining the fast performance. And anti-tampering, there are guards available based on the tool which you select it. You will have control over your code so that you don't really worry about the code from reverse engineering or changing the flow of your APIs or functionality. Okay, next slide. Okay, of course, just it's not it will not reverse engineer, but it will allow you to refrain from reverse engineering because if you use the proper tools, right, you can't really make out of it. Next. Okay. Okay, to summarize it, we covered two different topics. One is interface protection and obfuscation. Interface protection, you make sure that you harden the permissions and you need to have a secure storage and make sure to do an input validation and strong recommend to do a code signing. This is one of the way, and leverage ProGuard or beyond that one, what is available, what is the selection you want to make it up. The benefits is application security, and it reduces the risk of data breaches, definitely, because you can avoid the kind of injection just now we saw it, right? You can avoid those kind of things, because if I don't understand your code flow, I can't really do an injection. And obfuscation will help in help in protecting the code from reverse engineering, and at least reduce the risk of reverse engineering. Exploitation is the major key thing here. Okay, next slide. There are a couple of references you can always go. Google provides strong guidelines and privacy guidelines in implementing applications. One is for the developers, and other one is for the attackers, like for reverse engineering. So, as a security person, you have to balance both. That's the key takeaway. In developer, I make sure that I follow the Google recommendations. As an attacker, if you think that, right, okay, what are the tools available, I can use it. But still, as a security person, I make sure that even though I use these tools, if I follow the recommendations by using appropriate interface protections and obfuscation, I make sure that I cannot achieve anything by using any tools available. Okay. Next slide. Thank you.
All right, so I'm gonna start with the question and answers here. We're about the time, so we may not be able to go through all the questions, but I can see we have some of them here. Let's start with this one. The text was a little small and blurry. That was the issue during the demo. We will make sure to share the video with you on our social channel as well as on the YouTube. So hope that will solve the problem here. Now we got another question here. Can ProGuard protect assets such as JPG, JSON too?
No.
All right.
ProGuard is only string class renaming and very basic functionalities, not the asset protection. For that, you require advanced obfuscation tools.
Great. We have another question here. How can sharing services between two apps in a secure way? You mentioned key should be the same. Is it possible to have the same signing key for two apps?
No, it is not recommended to share the same key for two services. But what I mean here is the key here. The key means the application which you are going to sign must be same as after the application which you are going to consume it. Okay, service, if it is signed with one key, it must be signed with the same key the receiving application. That means the handshake is proper.
All right. We have another question here about how can I test the effectiveness of my interface protection?
Okay, so once you done the interface protection, there are tools available like static analysis code. You can see that mobile stuff, and there are many tools available today. OWSSP providing a lot of tools. You can do reverse engineering. It will scan your application. It will provide a report, or you can do dynamic analysis. Or if your application, if you are too much keen on it, we recommend for a hire a third party to evaluate your application. It's called pen testing actually. But before going for pen testing, right, you can always do whatever I showed in this demo, right? You can try to use the open source, try to do reverse engineering, try to see that if you can able to use the service which are exporting it, and see that if you're able to change the inject the code inside your application.
Great. What are the limitation drawbacks if I obfuscate my application?
Yeah, so okay, something like this, right? You blurred something, that means you can't really see it. What are the generates? Similarly, it's not limited to the reverse engineering, seeing the code. It affects your debugging log capability also, because the logs which it generates are also obfuscated. So there are tools available to deobfuscate, because while you're obfuscating, right, it will generate a master key for you. So using that one, the captured logs along with the master files, combining these two using the tools, you can you can de-obfuscate the logs. So that's a challenge actually. It's not that it's a drawback. It's a challenge, and increases developers' life a little bit harder to de-obfuscate the logs.
Thank you. We have another question that just came. How can we find a sweet spot of performance, energy consuming also at runtime, versus obfuscation protection?
I missed the question fully. Okay.
Let me repeat the question again. And I also would like to know, I also would like to tell here that we are also joined by Erwin Cormer, who's also here to help us answer any questions. So here is the question for you two. How can we find a sweet spot of performance versus obfuscation?
Mm. I'm still trying to understand the context, but still, you want
Yeah,
to help
hi,
out?
this is Irv. I'm a
Okay.
fellow of engineering, and my discipline is security, and I've been doing this for close to 40 years. The question here is quite interesting. If I use obfuscation and get, if you will, performance reduction in size, where does my sweet spot, is what you're saying? At what point do I quit, if you will, lay off on the obfuscation, or find that obfuscation becomes either detrimental or performance enhancing? Some of it's going to depend very much upon the application that you're writing and what you're doing. The use of energy, I think you were talking about battery consumption at runtime. Also a very interesting question. I'd like to chat or do some research on this, but I couldn't give you what I'd say a straight answer off the top of my head without knowing a lot of detail about the application you're running, if you will, and what it's doing in its operational environment, how it's actually being exercised. So the obfuscation, like I said, the protection side of this will give you some, as Cyron's, told you, but finding a sweet spot could be very difficult.
Yeah, that's why I mentioned it's a balanced one, because we don't want you to obfuscate completely, because it is in runtime. It will take a lot of time to deobfuscate and provide the open the APIs for consumptions. So
Great. Thank you so much. Hope that answers your question, Buddhika. And if you have any other questions, please feel free to reach out to us at developer@zebra.com, and we will try our best to get back to you with the answers. So with that, our session wraps up for today. Thank you, Sairam. Thank you, Erwin. We really appreciate it. And to our audience, please keep an eye out for a quick survey. It will be popped up as soon as the webinar ends. And if you can, please just take a minute or two to let us know about your thoughts. We value your feedback and we look forward to seeing you again. Thank you so much.